Volt's electrical software has a reputation for generally accurate results, although occasional discrepancies have been reported. These discrepancies are often due to user errors or specific scenarios that the software may not handle perfectly. Overall, Volts is considered a reliable tool for electrical calculations, but like any software, it has its limitations. Independent testing has been conducted on Volts and other electrical calculation software. Results have shown that Volts performs well in most cases, with accuracy levels comparable to other industry standard software. The user community for Volts is generally positive. Many engineers appreciate its comprehensive capabilities and user-friendly interface. However, there have been some reports of issues and limitations which Dolphin software typically addresses with updates. It is always advisable to check the results of any electrical calculation software, including Volts. This can be done by comparing the results to known values or using a different software program to verify the calculations. The professional version of Volts offers additional features and support, which may be valuable for larger projects or complex calculations. The professional version of Volts is relatively expensive, so consider your budget and the specific needs of your projects. There are other electrical calculation software programs available, such as ETAP and SKM Power Tools. Consider evaluating these options to find the best fit for your requirements. If you have thoroughly evaluated Volts and are satisfied with its capabilities, accuracy, and support, it can be a valuable tool for your electrical calculations. However, it is important to use the software carefully, check your results, and consider alternative options if necessary. When using electrical calculation software like Volts, it is crucial to understand its strengths and weaknesses. Like any software, it is not foolproof, and relying solely on its output without proper verification can lead to errors. Firstly, always double-check the input data. Ensure that all parameters, such as voltage levels, conductor sizes, conduit types, and ambient temperatures, are entered correctly. Even a small error in the input can significantly affect the final results. Secondly, be aware of the software's limitations. Volts, like other electrical calculation software, may not perfectly model every possible scenario. Complex systems with nonlinear loads, harmonic distortion, or unusual grounding configurations may require additional analysis and judgment. Thirdly, compare the results with known values or rules of thumb. For example, check if the calculated voltage drop is within acceptable limits according to the National Electrical Code. Verify that the conductor ampacity is adequate for the applied load and that the overcurrent protection device is properly sized. Fourthly, use a different software program or manual calculations to verify the results. If possible, compare the Volts output with the results obtained from another reputable electrical calculation software or perform hand calculations to confirm the accuracy. Fifthly, stay updated with the latest version of the software. Dolphin Software and other software vendors regularly release updates to address bugs, improve accuracy, and add new features. Ensure that you are using the latest version to benefit from these improvements. Sixthly, understand the underlying assumptions and algorithms used by the software. Volts, like other electrical calculation software, uses specific formulas and algorithms to perform its calculations. Understanding these underlying principles can help you interpret the results and identify potential errors. Seventhly, seek training and support. Dolphin Software and other software vendors offer training courses and support resources to help users learn how to use the software effectively. Take advantage of these resources to improve your understanding of the software and its capabilities. Eighthly, document your calculations. Keep a record of all input data, assumptions, and results. This documentation can be helpful for troubleshooting errors, verifying compliance with codes and standards, and communicating your findings to others. Ninthly, exercise professional judgment. Electrical calculation software is a valuable tool, but it should not replace your own professional judgment. Always review the results carefully and consider all relevant factors before making any decisions. Tenthly, consult with experienced engineers. If you are unsure about the results of your calculations or have any questions about the software, consult with experienced electrical engineers who can provide guidance and support. In addition to these general tips, there are some specific considerations to keep in mind when using Volts. Volts is known for its comprehensive capabilities, but it can also be complex to use. Take the time to learn the software thoroughly and understand all of its features. Volts allows you to customize various settings and parameters. Be sure to understand the impact of these settings on the results. Volts provides detailed reports that can be helpful for documenting your calculations and communicating your findings to others. Take advantage of these reports and customize them to meet your specific needs. Volts has a user community forum where you can ask questions and share your experiences with other users. Take advantage of this forum to learn from others and get help with any issues you may encounter. Ultimately, the decision of whether to purchase the professional version of Volts depends on your specific needs and budget. If you are working on large projects or complex calculations, the additional features and support offered by the professional version may be worth the investment. However, if you are only using the software for simple calculations, the standard version may be sufficient. Before making a decision, consider the cost of the software, the features you need, the level of support you require, and the availability of alternative software programs. By carefully evaluating these factors, you can make an informed decision that is right for you. Remember that electrical calculation software is a tool to aid in design, but it should not replace fundamental electrical engineering knowledge and sound judgment. When evaluating electrical calculation software, consider several factors beyond just the initial cost of the software itself. Firstly, consider the cost of training. How much time and money will it take to train yourself and your staff to effectively use the software? Secondly, consider the cost of updates and maintenance. Many software vendors charge annual fees for updates and maintenance, which can add up over time. Thirdly, consider the cost of support. How much will it cost to get technical support from the vendor if you encounter problems or have questions? Fourthly, consider the cost of integration. How well does the software integrate with other software programs that you use, such as computer-aided design software or building information modeling software? Fifthly, consider the cost of hardware. Does the software require any special hardware, such as a powerful computer or a high-resolution monitor? Sixthly, consider the cost of downtime. How much downtime will you experience if the software crashes or malfunctions? Seventhly, consider the cost of errors. How much will it cost to correct errors that are caused by the software? Eighthly, consider the cost of compliance. Does the software help you comply with relevant codes and standards, such as the National Electrical Code? Ninthly, consider the cost of security. Is the software secure and protected from cyber threats? Tenthly, consider the cost of obsolescence. How long will the software be supported by the vendor, and what will it cost to upgrade to a newer version when it becomes obsolete? By considering all of these costs, you can get a more accurate picture of the total cost of ownership of electrical calculation software. When performing electrical calculations, it is important to understand the different types of loads that you may encounter. Firstly, resistive loads are loads that convert electrical energy directly into heat, such as incandescent light bulbs, electric heaters, and toasters. Secondly, inductive loads are loads that store energy in a magnetic field, such as motors, transformers, and inductors. Thirdly, capacitive loads are loads that store energy in an electric field, such as capacitors and lawn cables. Fourthly, nonlinear loads are loads that draw current in a non-sinusoidal waveform, such as electronic devices, computers, and fluorescent lights. Each type of load has different characteristics that can affect the electrical system. Resistive loads draw current that is in phase with the voltage, while inductive loads draw current that lags behind the voltage. Capacitive loads draw current that leads the voltage. Nonlinear loads can cause harmonic distortion, which can damage equipment and interfere with other electrical systems. When performing electrical calculations, it is important to take into account the type of load that you are dealing with. For example, when calculating the voltage drop in a circuit, you need to consider the impedance of the conductors and the type of load. For resistive loads, you can use Ohm's law to calculate the voltage drop. For inductive and capacitive loads, you need to use more complex formulas that take into account the phase angle between the voltage and current. For nonlinear loads, you need to use harmonic analysis techniques to determine the harmonic distortion and its impact on the electrical system. In addition to the type of load, it is also important to consider the load factor. The load factor is the ratio of the average load to the peak load over a given period of time. A high load factor indicates that the load is relatively constant, while a low load factor indicates that the load is highly variable. The load factor can affect the size of the conductors, transformers, and other equipment in the electrical system. For example, if the load factor is low, you may need to oversize the equipment to accommodate the peak load. When performing electrical calculations, it is important to use accurate data and assumptions. The accuracy of your results depends on the accuracy of your input data. Make sure that you have accurate information about the voltage levels, conductor sizes, conduit types, ambient temperatures, and other parameters of the electrical system. Also, be aware of any assumptions that you are making. For example, you may be assuming that the load is constant or that the ambient temperature is constant. If your assumptions are not valid, your results may be inaccurate. When performing electrical calculations, it is important to use the correct units. Make sure that you are using the correct units for voltage, current, resistance, impedance, power, and other electrical quantities. Using the wrong units can lead to significant errors. For example, if you are calculating the voltage drop in a circuit, you need to use the correct units for voltage, current, and resistance. The voltage is typically measured in volts, the current is typically measured in amps, and the resistance is typically measured in ohms. If you use the wrong units, you will get an incorrect result. When performing electrical calculations, it is important to check your results. After you have completed your calculations, take the time to check your results for accuracy. Make sure that your results are reasonable and that they make sense. If you find any errors, correct them and recheck your results. Checking your results can help you avoid costly mistakes. When performing electrical calculations, it is important to document your work. Keep a record of all of your input data, assumptions, calculations, and results. This documentation can be helpful for troubleshooting errors, verifying compliance with codes and standards, and communicating your findings to others. Documentation can also be helpful for future projects. If you need to perform similar calculations in the future, you can refer to your previous documentation to save time and effort. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. It is important to adhere to the NEC when designing and installing electrical systems. The NEC contains numerous tables and articles that provide guidance on various aspects of electrical design and installation, including conductor sizing, overcurrent protection, grounding, and wiring methods. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on their size, insulation type, and ambient temperature. NEC Article 250 provides requirements for grounding and bonding electrical systems. NEC Article 310 provides requirements for conductors for general wiring. It is crucial to consult the latest edition of the NEC and any applicable local amendments when performing electrical calculations and designing electrical systems. Failure to comply with the NEC can result in unsafe installations and potential hazards. In addition to the NEC, there may be other applicable codes and standards that you need to consider. For example, if you are designing an electrical system for a healthcare facility, you may need to comply with the requirements of NFPA 99, Standard for Healthcare Facilities. If you are designing an electrical system for an industrial facility, you may need to comply with the requirements of OSHA regulations. It is important to be aware of all applicable codes and standards and to ensure that your designs comply with these requirements. When working with electrical systems, safety is paramount. Always follow safe work practices and use appropriate personal protective equipment, or PPE, before working on any electrical equipment. To energize the circuit and verify that it is energized using a voltage tester. Wear appropriate PPE, such as safety glasses, gloves, and arc-rated clothing to protect yourself from electrical hazards. Be aware of the potential hazards of electricity and take steps to mitigate these risks. Electrical calculation software can be a valuable tool for electrical engineers and designers, but it is important to use it carefully and responsibly. By following the tips and guidelines outlined above, you can ensure that your calculations are accurate and that your designs are safe and compliant with applicable codes and standards. Always remember to exercise professional judgment and to consult with experienced engineers when necessary.